Hello, this is our Polynomials unit, Unit 7. This is day 9. We're going to talk about dividing polynomials. So thanks for watching. First, we're going to consider our problem, and we're going to factor the numerator and the denominator separately. Always, when you're factoring, you want to see if there's a greatest common factor you can pull out first. Then you're going to factor you have several options for which method you're going to use. What we're looking for is two factors that could cancel each other out. So the same factor in the numerator that you have in the denominator. That's what we're hoping for. Okay. Also, if you have any remaining factors, especially if you have like monomials, remember that if you have the same base, you take the exponent of the first minus the exponent of the second. And that's your answer for something like that. Okay, so here's an example. If I have 27x squared minus 15x all divided by 12, so this is just dividing by a monomial, right? I'm going to factor my numerator, so I can see that I can pull out 3x from each of these terms, right? So I have 3x times 9x minus 5. Okay, I now see that 3 and 12 both have, you can imagine that 12 is really 3 times 4 if you really wanted to think of it that way, right? We can cancel 3 and 3. 3 divided by 3 is just 1. Okay, and so what we are left with is x times 9x minus 5 all over 4. All right, over here, example 2, I have a trinomial divided by a binomial, and so what I want to do is factor the numerator and factor the denominator if you can, but I'm going to factor the numerator and hope that one of my two factors will cancel out with that x plus 5. Okay, very often it will for the problems that we are giving you to practice. So if I think about x squared plus 3x minus 10, remember we're going to use our x puzzle to figure out two numbers that multiply to give us negative 10, but add to give us 3. And so that's going to be it's going to be positive 5 and negative 2, right? Those are my magic numbers. So I factored x squared plus 3x minus 10, and I got x plus 5 times x minus 2. And my denominator was already x plus 5. So anything divided by itself is just 1. So x plus 5 divided by x plus 5 is 1, right? 1 times x minus 2 leaves me with x minus 2, and that's my answer. All right. So you can cancel out common factors. Factors are things that are being multiplied together. Okay, so if I have a 6 over 9 and I break the 6 into its factors 2 times 3, I break my 9 into its factors 3 times 3. Notice we're multiplying factors, right? So 3 divided by 3, those cancel each other out, and I'm left with 2/3. However, we cannot cancel out common terms. Terms are things that are added or subtracted, right? So be super careful here, right? 5 over 6, I can write as 2 plus 3 over 3 plus 3. That is absolutely the truth, right? But I can't cancel, so no, don't do this. I can't cancel those 3's because we're adding them. They're not factors. And 5/6 doesn't equal 2/3 because 2/3 equals 4/6, right? Okay, so anyway, just be really, really careful. You can cancel out things that are being multiplied together, but you cannot cancel out things that are being added. So over here, if I have x plus 5 all over x, this is another thing that you need to think about. If I'm dividing that x into the numerator, it has to go to everybody, not just the one that I want it to go into, right? So this could be, x over x plus 5 over x. I'm allowed to do that, so it could be 1 plus 5 over x. I don't know that that's any better, but it's true. It is not, however, 5. I cannot just cancel those x's out. All right, so I can't, oh, and there you go. Sorry, I should have looked ahead. So what I just did is what we did down here. X plus 5 over x I know is the same as x over x plus 5 over x. X over x is 1 because anything divided by itself is 1 plus 5 over x. Sorry for not looking ahead there. Whoops. All right, so we're going to simplify the following expressions. In this case, I have a binomial divided by a monomial. So a couple ways that I can do this. I'm actually going to pull out 2x here, and I'm left with x minus 3. This is over 6x squared. You guys know that 6x squared is the same as 2x times 3x, right? 2 times 3 is 6, x times x is x squared. I'm not always going to do it this way. I'm just kind of breaking it all the way up so you can see. So 2x divided by 2x is just 1, and my answer would be x minus 3 all over 3x. That's probably how I would leave that answer. Okay, over here, I'm going to factor out what I can. So I'm going to look for a greatest common factor. In my numerator, I can pull out x. So I have x times x minus 3 in my numerator, right? In my denominator, I'm going to factor that. So using my x puzzle, I need two numbers that multiply to give me 6, but they're going to add to give me negative 5. I think that's negative 2 times negative 3. Negative 2 times negative 3 is positive 6, and negative 2 plus negative 3 is negative 5. So those are my magic numbers, so I'm going to say that this is x minus 2 times x minus 3. So I really haven't changed anything except for the way the numerator looks and the way the denominator looks, but they're still all the same values, right? Now I see x minus 3 in the top and x minus 3 in the bottom, and everything's being multiplied up top, x times x minus 3, x minus 2 times x minus 3. So these are factors. X minus 3 and x minus 3 cancel, and so my answer is x over x minus 2. Okay, so look at the back. Here I have 3x squared minus 18x divided by, that's divided by negative 9x squared. I'm going to go ahead and rewrite this as a fraction. It just is the way I think about it. So I'm going to say that this is 3x times x minus 6. So I'm doing two steps in one, right? I factored out the greatest common factor there. And instead of saying divided by, I'm going to write this as negative 9x squared. Okay, so here I know 3 goes into 3 one time, 3 goes into negative 9 negative 3 times. So I have negative 3 there. X goes into x one time, and x goes into x squared one time. So this is a way that I can look at this. X minus 6 over, I now have negative 3x. If you wanted to, you could have written this as 3x times x minus 6 over, I had negative 9x squared, right? So I could say that's 3x times negative 3x. See, 3 times negative 3 is negative 9, x times x is x squared. So I can do it that way if it's easier for me to see. It's not easier for me to see on this video when I use that little light green, is it? Okay, in any case, that's my answer. You don't have to have those parentheses. They're just left over there because that's what I had as a factor. Okay, so over here, 2x squared plus 11x minus 6. I need two numbers that multiply to give me negative 12. They're going to add to give me 11. And so I think that's 12 and negative 1. 12 times negative 1 is negative 12. 12 plus negative 1 is 11. Okay. If I want to solve, I can solve by grouping, or I can use my box, right? So if I do this by grouping, it's 2x squared plus 12x minus 11, minus 1x. Hold on. Let's make that look neat. Okay. All right. 2x squared, and instead of 11x, I'm going to say plus 12x minus 1x, or minus x, and then minus 6, right? All I did was I broke up 11x so that it's 12x minus x. Okay, this is still all divided by x plus 6 in parentheses. Okay, so now I'm going to factor. I have 2x times x plus 6 minus 1 times x plus 6. It's all divided by x plus 6, and I prefer to see it as a fraction, so that's why I write it that way. Okay, I can see that I'm going to pull x plus 6 from each of these terms. This is kind of like a super term. This is a super term. So I can see that I'm going to be left with 2x minus 1, but if you want to write it out as 2x minus 1 times x plus 6 all over x plus 6, that might be safer. This cancels, and my answer is, can you see it if I slide over? 2x minus 1. All right. Looking at negative x squared plus 4. When you have a negative leading coefficient, pull out a negative. It's just going to make your numbers work out better, I promise. Also, you're going to see something fun when we do this. Okay, I'm going to take out a negative from each of these terms. So I have negative times x squared minus 4, right? Because 4 divided by negative 1 is negative 4. What do you see? You see a difference of squares, yeah? Okay. Down here, x squared minus x minus 2. I need two numbers that multiply to give me negative 2, but add to give me negative 1. So that's going to be negative 2 times positive 1 is negative 2. Negative 2 plus positive 1 is negative 1. My leading coefficient is a 1, so I just get to drop those magic numbers in. Okay, right now it looks like I don't have anything that I can take out, but wait. Let's rewrite this. It's a difference of squares, so it's x plus 2 times x minus 2, right? All over x minus 2 times x plus 1. Those two factors cancel. And so my answer is going to be the negative of x plus 2 all over x plus 1. You can have the parentheses or not, it's up to you. Okay, x cubed minus x, you're going to see the same thing. It's going to be x times x squared minus 1, right? Which is going to be x times x plus 1 times x minus 1. With me? X squared minus 1 is a difference of squares. So that's my numerator. My denominator, I'm going to pull out an x. Okay, so it's going to be x times x squared minus 5x minus 6. Didn't we just do this a minute ago? I swear we did. Maybe it was on the other side. Okay, x squared minus 5x minus 6. I still have x, and I know that I'm going to have, let's see, two numbers that multiply to give me negative 6, but add to give me negative 5. Is it negative 6 and 1? Negative 6 times 1 is negative 6. Negative 6 plus 1 is negative 5. So I'm going to have x minus 6 times x plus 1. So I see some things I can cancel. Get rid of the x plus 1, x plus 1. Okay, and x divided by x, yeah? So my answer is going to be what's left, x minus 1 over x minus 6. See, all I had in the numerator was x minus 1. All I had in the denominator was x minus 6. Okay. 2x squared plus x minus 10. You do always want to see if there's a greatest common factor that you can pull out every single time, and we cannot. So I need, for my numerator, I need to figure out two numbers that multiply to give me negative 10, right, and add to give me 1. And so, oh, I lied. 2 times negative 10 is negative 20. Forgive me. Forgive me. Multiply to give me negative 20 and add together to give me 1. So I'm going to say that that is 5 times negative 4 gives me negative 20. 5 minus 4 is 1. Okay, so this is just for the numerator. My numerator is going to be 2x squared plus 5x minus 4x minus 10. That's my numerator. My denominator, I can't pull any common factor out, so I need two numbers that multiply to give me negative 60. And they have to add to give me 4. Okay, and so that is going to be 10 times negative 6. 10 times negative 6 is negative 60. 10 minus 6 is 4. Okay, so I'm going to do this by grouping as well, and I have 4x squared. Instead of 4x, I'm going to say plus 10x minus 6x, right? And still minus 15. So let's group this thing up and see what we can do. I have 2. Nope. Just kidding. Gosh. Oh my gosh. I have x that I can pull out of my first 2. Just kidding. I have x times 2x plus 5 minus 2 times 2x plus 5. Is this true? 2x squared plus 5x. Yes. Negative 4x minus 10. Yes. Okay. So that's my numerator. My denominator, I'm going to pull out 2x. I have 2x plus 5. I'm going to pull out negative 3, and I have 2x plus 5. Whoa, look at that. That's a lot of 2x plus 5s. So let's see what happens when we do all that. Okay. I'm going to say that my new numerator is x minus 2 times 2x plus 5, right? 2x plus 5 times x minus 2, right? My new denominator is going to be 2x plus 5 times 2x minus 3. Okay, 2x plus 5 divided by 2x plus 5 is just 1, and so I believe my answer is x minus 2 over 2x minus 3, like that. Okay, try some of these on your own. You can put the video on pause and then come back and see if you get these same answers. That way you make sure that you're keeping up with everything. But maybe take a look at number 8. I'm just going to say that we are going to multiply everything straight across, okay? Because that's how multiplication of fractions works. I'm going to multiply everything straight across. Except for I'm not really going to. It's just that I know that this is really one big fraction. So once I break up this trinomial and this binomial, I'm going to have a whole bunch of factors in the numerator and a whole bunch of factors in the denominator, and I'm going to see what I can simplify or cancel out. Okay, so you pause, you try it, you come back. All right, so looking at number 8, I'm going to redo my numerator. My numerator is going to be x plus 1 still. X squared minus 5x plus 6 should be x minus 2 times x minus 3. Right, so x squared minus 5x plus 6. Yes, that worked. Down here, I'm going to pull out 4. So I have 4 times x minus 3. Still times x minus 2. So I'm not going to multiply stuff out. I'm just looking at my factors to see what I can cancel now. Well, hooray, x minus 2 divided by x minus 2, those cancel, yeah? X minus 3 divided by x minus 3, those cancel. And so once I pulled it into factors, I was able to quickly see what was left, and that's my answer. Okay, let's take a look again. I know that the way we multiply fractions is you multiply the numerators together and then you multiply the denominators together. So I'm just carrying over, right? We're just going to do that multiplication, except not really, because I'm actually going to leave things as they are and factor more things out. So x squared plus x is going to be x times x plus 1, still times x minus 2. Down here, this is a difference of squares, so I know I have x plus 1 times x minus 1, still times 3x, which I'm going to stick in the front because I prefer to have my monomial in the front. Okay, what can I cancel? X plus 1 and x plus 1 cancel. X and x cancel. And so I'm left with x minus 2 in the numerator over 3 times x minus 1 in the denominator. All right. Again here, I'm going to just, I know I'm multiplying the whole numerator times the numerator. I'm going to multiply the whole denominator times the whole denominator, so it's really one big giant fraction. So let's break up m squared plus 11m minus 42. Two numbers that multiply to give me 42, but add to give me 11. I think it's 3 and 14, but I need negatives. It's going to be 14 times negative 3 is negative 42, and 14 minus 3 is 11. So those are my numbers that I need for m squared plus 11m minus 42. So let's go ahead and write that. Okay, my numerator is now m plus 14 times m minus 3, all times 39m. So if I say 39m, why am I writing 29m? That is a great question. Times 39m. Okay, in my denominator, I'm going to break that up. That looks like it's 26 times m minus 2 times m minus 3. Okay, so m minus 3, those cancel. 39 and 26. I think that, hold on. I think those are both divisible by 13. That took me far longer than it should have. I'm going to say 13 goes into 39 3 times. 13 goes into 26 2 times. So what I'm left with is m plus 14 times 3m, but I want 3m. I want my monomial first. So 3m times m plus 14, right? I had m plus 14 and I had 3m. My denominator, this is 2 times m minus 2. So that is my final answer, 3m times m plus 14, all over 2 times m minus 2. Okay, so let's check it out. We're going to break this up, and I see 3x cubed plus 16x squared minus 35x. The only thing I can pull is an x. So my numerator is currently x times 3x squared plus 16x minus 35. My denominator, I can't pull anything out. So let's look at the numerator. I need two numbers right here. This is my numerator. Two numbers that are going to multiply to give me negative 105, right? 3 times negative 35. But they have to add up to give me 16. And so 5 goes in, let's see, we're going to say it's negative 5 times 21. Okay, my denominator, 2x squared plus 11x minus 21, my denominator is going to be negative 42 and positive 11, two numbers that multiply to give me negative 42, but add to give me 11. We're back to 14 and negative 3. I think we talked about that in a different problem. Okay, so I'm needing to find out my factors. Just for kicks, because we've been using the grouping method, I'm going to switch it up. I'm going to use the box method to work through 3x squared plus 16x minus 35, okay? These are my magic numbers for that, right? 3x squared plus 16 minus 35. I needed two numbers that multiply to give me negative 105, and they have to add together to give me 16. So if I use the box, I'm going to plug in this term, 3x squared. My last term goes down here, negative 35. And I have negative 5x and 21x. I got that from my magic numbers. When I look from the top down, I can pull 3x. Top down, I can pull negative 1. That's it. Left to right, I can take an x, and left to right, I can take a 7. So my numerator is x times, I just broke up 3x squared plus 16x minus 35 into 3x minus 1 times x plus 7. You could have done that with grouping as well. Okay, so that was just my numerator. My denominator, 2x squared plus 11x minus 21, we got to figure that out, right? Here's my magic numbers for my denominator, and so I'm going to plug these pieces of information in to a new box. Okay, my top left is going to be 2x squared. My bottom right is negative 21. And I just found 14x and negative 3x. So looking down, I see that I can pull 2x and I can pull negative 3. Looking across, I can pull x and I can pull 7. Okay, so my denominator then is 2x minus 3 times x plus 7. Well, how convenient. I have x plus 7 divided by x plus 7. That goes away. And this is all I'm left with. So I know this is my answer. X times 3x minus 1 all over 2x minus 3. I just still had x times 3x minus 1 all over 2x minus 3. So great. Thanks for watching. And we are about wrapping up our unit right now. So good luck on your final for the unit.